Welcome to episode 233 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm all right, Rob. How are you doing?
Doing fine. You had a little announcement to make, right?
Yeah, so I've got two classes that are coming up in Stuttgart at the end of September and right into the first day of October there, which are on writing correct performant code and taking advantage of compile time const expert templates topics. So I just suggest that our listeners go and check those out. We'll link to those in the notes. Anyone can sign up for them.
Yeah, we'll definitely put those in the show notes. And are you going to Stuttgart just for these courses, or did you already have plans to be there for a conference or something?
No, that's just for these courses.
Oh, wow. That's great. Okay. Well, at the top of every episode, I'd like to trade a piece of feedback. We got this comment on the website, and unfortunately, we got a couple similar comments on Reddit. So this one was from Matt Dawson saying, very excited about this topic, but audio quality for the guest was very poor, and I eventually gave up. I guess this is the exception, which proves the rule, as the audio quality on CppCast is usually great. I really want to apologize for the poor audio quality. Both apologize to our listeners and to the guest, because listeners weren't able to really hear what Vadim had to say. We were just talking before the show how maybe we'll invite him on to kind of do a redo. We've never done a redo before, but
we have not.
But it would be nice to have Vadim on, make sure he has some better audio equipment beforehand. And we'll make sure that we don't let that sort of thing happen again. We kind of both thought at the beginning of the interview that, this isn't great, but we've scrubbed, somewhat poor audio before, but it just was a lot worse than we thought it was.
Yeah, and it kind of seemed like the quality was coming and going a little bit more. Like when he was doing the majority of the talking, it seemed like the audio was, from my perspective, better. So I thought that it would be something that we could clean up and the listener would never really notice. But that's not how it worked out.
Yeah, unfortunately not. So we will definitely keep this in mind and try to be better. Apologize, again, to all listeners who weren't able to stick it through the whole episode because of the quality, though. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is John Lakos. John is author of the large-scale C++ software design, serves at Bloomberg LP in New York City as a senior architect and mentor for C++ software development worldwide. He is also an active voting member of the C++ Standards Committee's Evolution Working Group. Previously, Dr. Lakos directed the design and development of infrastructure libraries for proprietary analytic financial applications at Bear Stearns. For 12 years prior, Dr. Lakos developed large frameworks and advanced ICCAD applications at Mentor Graphics, for which he holds multiple software patents. His academic credentials include a PhD in computer science and a SCD in electrical engineering from Columbia University. Dr. Lakos received his undergraduate degree from MIT in mathematics and computer science. His new book, the first volume of which is entitled Large Scale C++ Volume 1, Process and Architecture, is now available from Pearson Education. John, welcome to the show.
Well, thank you very much for having me. It's a pleasure to be here.
I have not, I don't believe, ever heard anything about your history with Mentor Graphics in the past. I'm kind of curious what you worked on there, if you can mention more about it.
Be happy to. It's been, it's been 23 years since I left Mentor Graphics. And I published my first book while I was at Mentor Graphics based on the knowledge that I gained from working there. I was there 11 years, and we worked on very large scale at the time software systems. And what we worked on is CAD tools. We had routers. We had visual editors. And my particular contribution was I'm going to say it's a device and wire extraction and recognition system so that you could take layout that was just handmade layout, extract all the transistors and the contacts and whatever, so you get all the devices out. Then the second patent is to extract the wires using all angle geometry, and I took advantage of vector calculus to make that super quick. And in fact, being able to extract a 200 segment wire is something that seems like a really hard problem to people. And what's fantastic is that the early part of this book that I just wrote captures the power of what's called dynamic programming or memoization, so that even though it seems like an exponentially hard problem, it's really a very simple quadratic problem if you get it right. And so again, using that wonderful technique, I was able to do very, very large problems in what seemed like, an impossibly short time. And it was quite successful. We could extract entire semi-standard libraries. We could extract them, retarget them to a different technology, and then put them out. What would take a year could be done in a few days. It was pretty spectacular.
So interesting. It sounds like, if I might read a little bit between the lines, that the work that you did on graphics early on, even though it seems completely unrelated to the financial industry today, is still helping you. What you learned there is helping you today still.
Well, when we say mentor graphics, graphics is, it's really CAD, right? It's really computer-aided design. And yes, there's some graphical rendering and whatever, but it's more like, it's hard geometry and math and compaction and algorithms. It's not quite graphics. I just want to be clear. It's not the front end kind of graphics. It's the back end kind of graphics. And yes, the back end kind of graphics is rife with very interesting, very hard problems that require heuristic solutions.
All right. Okay. Well, John, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about your book and maybe a little bit about the Prague ISO meeting next week, okay?
Sure thing.
Okay, so this first one is Freestyle C Rap. Victor Zverovich, who we have had on the show before to talk about format lib, I guess reached out to this British comedian YouTuber and was able to get him to do a freestyle rap about C++, which is pretty impressive because this guy, as he says in the video, knows absolutely nothing about programming, definitely knows nothing about C++, but he did a pretty good job making a relevant, on-the-fly rap about it.
Yeah, it's pretty funny.
Yeah. I don't have much else to say. Just go watch the video. It's funny.
I did have a chance to take a look at it, and I was impressed. Anything that's impromptu like that he's not a subject domain expert in, and getting that much nuance out of just a little bit of Googling, my hat's off to him. He's talented.
Yeah. And just for the record, Chris Turner, as far as I know, no relation to me.
I wonder if they're going to play this at the start of the Prague meeting, maybe? That'll be entertaining. Okay, and then the next thing we have is from Bartek's blog, and this is a C++20 reference card. And this is pretty neat. If you sign up for his mailing list, you can download it, and it has a pretty good, concise reference for all the new language and library features being added in C++20 that can fit on a page. Pretty cool that he was able to put this together, and you can get it for free.
Yeah, these kind of things are pretty neat.
And I also had an opportunity to look at that, and I thought it was a very handy way of at least knowing what your options are, and then if you need to know something more, you can always explore deeper. But just having the index is fantastic, is great.
Yeah, and he's put one out for C++17 as well, so if you need a refresher on what's been added over the past 4 years, you can look at both.
He's constantly producing little downloadable things like this, and yeah, you have to sign up for his mailing list, but not that big of a deal, really.
Yeah, free mailing list. Okay, so John, as we mentioned in your bio, you just released Large Scale C++ Volume 1, Process and Architecture, and you mentioned that you had your original book, C++ or Large Scale C++ Software Design. Is the new book kind of an update to the first one, or is it all new material?
So that's a good question, and the answer is a little bit of both, but not really. So it has to be, because there's nothing in the old book that I would take back particularly. I take it back. There's one place back in the day where I had a diagram and I had a string and a word, and I used derivation to show as a sort of an off the cuff dependency example, and I wrongly, and I'll never live it down, wrongly derived word from string, saying that a word is a string that has more restrictions on its on itself. And of course, because of slicing and all the other things that we all know are just terrible, I was never forgiven. There was a gentleman, I'll just say his first name, Dat, who made it very clear to me many times forever that I just didn't know what I was talking about. And I quickly conceded, yep, and oh my goodness. It doesn't matter. There's no excuse for putting something in that's wrong to show something that's right. So I take full responsibility for that. And now that's off my chest, and everything else I stand by. So this new book, and there's one other story I can tell you. When I wrote that book, I have to give credit to John Waite at Addison Wesley at the time, because the reason I even wrote that other book is I was working at Columbia, and someone called me, or I got a flyer in the mail saying, do I want to get a desk copy of this other book that was a good book? I don't remember which one it was, but it was one good book of the day. And I said, absolutely. And so I let them know, and they said, well, how do we know that you work at Columbia? And I was like, wait, you sent me the desk reference. And then I got a little, as my friend Sean would say, howly, and I said, do you realize I'm even thinking of writing a book, and it would be on large scale C++ and da-da-da-da. The next thing I know, John Waite flies out to see me, and next thing I know, I'm writing a book. So that's actually in the 1996 book. That started in 93. And what I wrote about in that book, they wanted me to write a book called Large Scale C++ Software Development. And I didn't know about development. I was a kid of 34. How would I know anything about development? But I did know about design, or at least I thought I did, except for that one thing that I got wrong. Never happened again, not in a million years. But so I started writing this, and it did take me about 14 months to come up with the first draft. But then there were some appendices that I felt were absolutely essential to get right, and that took another maybe another year, and then finally doing all the figures. There were like 400 figures in that book. And so that wound up taking another year. So by the time I finally published it, was July of 1996. And so anyway, that's Lakos 96. And, I'm good with that. But that book was not a complete treatment of C++ software design. It was really an architecture book. This book that you have here is part of a 3-volume series. It's the first part. I wrote the third volume first, which is verification and testing, because 21 years ago, when I started writing this book, I knew a whole lot about testing that I didn't get to put in the first book. So I wrote the third volume first, chapters 7 through 10. I literally wrote them. I have them. I published chapter 7 at C++ Connections in 2004. And I've been thinking about publishing this like every year since, but it just never, anyway, that happened. Finally, in about 2011, someone joined Bloomberg. His name is Jeffrey Olkin, and he is I'm jumping ahead. Prior to this, I needed somebody to help me do structural editing on the book, because the book was looking like it was on the order of 2,500 pages, and I needed just somebody else to bounce ideas off of. And Pearson was very generous and hired a structural editor. And the structural editor read the manuscript and says, there's a lot of stuff here. Unfortunately, even though he was a PhD in computer science and this was his job, he just said, I don't know. I can't help you. So anyway, now fast forward to 2011, when this fellow Jeffrey Olkin joined Bloomberg, and he's very important to me because back then I was very much into helping people write contracts. We might talk about that later. And I saw a paper written by somebody and who was a manager of another group, and I was reading it, and it was, it was okay, but it wasn't quite, stellar. Then all of a sudden around, I don't know, maybe it was page 13 or something, it became perfect English, just perfect. And I went over and said, what happened here? Oh yeah, I started this and I gave it to Jeffrey Olkin. I said, where's Jeffrey Olkin? So I found Jeffrey Olkin. Shortly after that, he became the structural editor of my book, and he read every word of this book and helped me rewrite it. So I owe him a ton as being my ghost sort of co-author. He didn't actually come up with the words and ideas per se, but he helped me structure it in a way that was coherent. So that I mean, that was really huge. So Many thanks to Jeffrey Olkin. So
Okay.
what's
So
this book? This book right here, this volume that I'm touching, is the physical design part of the 3-volume set. So the first volume is Process and Architecture. And it talks about the same kinds of things that the original book talked about. But the original book had 3 parts to it as well. It had sort of a preparation, then it had a notion of what physical design is, and then it had a little bit more on logical design. And the first book is known for the physical design contribution. And this book is all I tell you, all physical design. And then what's really nice about this is the final chapter, which is rather intimidating. It's about half the book, is how to apply physical design in large-scale software development. So that's what this book is in a nutshell-ish.
Okay, so you've mentioned the first book, and you told us that you already have the third book written, but you, as far as I know, didn't say anything at all about what the second volume is going to be.
Well, the second volume is called Design and Implementation, so it's got a fairly wide category. Chapter 4 really talks about some stuff that you just have to know it, and no one really talks about it. So the value of a value is the first section of Chapter 4. Chapter 4 is really about interfaces and such. And the next section is classifying classes, because I felt like being cute. The third one is value semantics, and the fourth one is vocabulary types. And those titles have been there since the 1990s. You know, they're just known, and I use them routinely. And I thought I understood value semantics pretty well back in 2001. Then right around 2008, an interesting story, I was in the process of getting something that's also near and dear to my heart, allocators properly into the standard. I know that's a touchy subject, and I do want to touch on it later, but it was pushed back, and I had to wait for the next meeting. And I was in one of those big rooms with no windows in Hawaii, and they were talking about like 25 men in T-shirts with laptops, and they were talking about a defect, and they were talking about a defect because in the wording of the standard where they said that these two pattern objects were the same, and people were going, well, what do you mean the same? Well, the same, that well, maybe they compare equal. What would happen if a copy construct, there was no wording. There was no way to say what they meant by the same. Literally, someone finally said things like, well, they're equal, they're equivalent. You know what I mean, but no one knew what they meant. Did it mean the same object? Did it mean that there was something about the two objects that was the same? What was it? And it turned out that what the two objects had that was the same is the same value. Well, what do we mean by value? And now we need to understand what salient attributes are. And so while I was there, I vowed, because I was just really upset that my proposal didn't go through. And I didn't say anything in the meeting because I said, these guys, come on, please. I said, I'm going to write a presentation, which I then presented at ACCU shortly thereafter. But it got me started. And it was right around the time that Alex Stepanov wrote his book on the elements of programming style. This is a true story. I got the book, Elements of Programming Style, and I started to read it, and I couldn't understand it, and I put it in my briefcase, and I left it there. And for years, I carried it around, and I had no idea what it said. Nothing. I just couldn't. I carried it with me. And then finally, I was asked to interview Alex Stepanov on his new book, From Mathematics to Generic Programming. And I said, damn it. All right. I got to go back and read the book. So I couldn't read the book. So I photocopied the pages and made the print really big. And I got past page 2 and discovered that chapter 1 of his book is all about value semantics. And I'm like, oh my God, if he just said so. Anyway, what's really wonderful is that the first chapter of Alex's book and the entire thesis that I have on value semantics is within, a micron of the same thing. And where they differ is so sort of nebulous and unimportant. I mean, it's because he comes from a more mathematical background, and I come from a more software engineering background, but we backed into it the same thing, pretty much the same thing, exactly the same thing. And it's very heartening to know that if you come at something from two different ways and you get the same answer, you're probably right. And that's the beauty of testing. If you can test something in a way that's completely different than the way you designed it, then you have a lot of confidence that it's right. So there's a lot of goodness in that. So anyway, where was I?
I think we're talking about what was in the second book, the second volume. Yeah.
In the second book, the notion of value semantics is covered. And towards the end of it, I mean, there's a lot about interfaces, and towards the end of it, which is end of the chapter 4, there is a dedicated section on memory allocation. And that's because memory allocation needs to be part of the interface of objects. And this is a contentious issue, and a lot of people can fairly say with a library-based solution for memory allocation, it's ugly, it's expensive to write, it's expensive to maintain. There's a lot of clutter in the interface, and if you're not one of the power users of memory allocation, you're not a games person, you're not at Wall Street or in a hedge fund, or you're trying to do low latency work, or you're not doing something in an embedded system, if you're not one of those guys, but you just want to use C++ because it's a cool language, it's a pain. It was not usable in C++ 03 because there were weasel words that said basically it doesn't have to work. In C++ 11, it still invaded the type system, which is why vocabulary types and templatized policies don't work well together. And so that was that. In C++ 17, we got the polymorphic memory resource, which my good buddy Pablo, that used to work for me and then went to Intel and now works for me, is in charge of. But it's not good enough, because as much good as memory allocation brings to performance, and as much good, ancillary good, that it does for being able to instrument at scale anything in production, and being able to place out whole objects in special memory, and rapid prototyping, and reduced risk, and even garbage collection in an arena, all of those things that you can do, that's not quite good enough. Why? Because the language solution doesn't allow interoperability with modern C++, aggregate initialization, or compiler-generated constructors and assignment. And so in order to get what you want, you A, have to write it all yourself and get it right, and B, you can't use it in fun ways like lambdas and so on. And so it's kind of But if you're not interested in the cool parts of C++, and all you want to do is get your job done, it's indispensable. Now, imagine that the language itself made your classes allocator aware, and they didn't show up in the constructors at all. So all you have to do is just say, I want to create this vector using this allocator. Done. And you never even knew that you wrote the class that was allocator aware, because there's no allocators in it. And it's kind of the same as making a function virtual. If you make it virtual, do you see all those pointers to functions that the compiler put in? No. You just know that it's polymorphic. God bless. So if we at Bloomberg, by the way, on this particular podcast, I'm speaking for me, but when I'm at the standards committee, I speak for Bloomberg. I'm the voting member. But I want to tell you that, for real, if I'm successful and this actually comes to pass, all of the allocators that we've been using at Bloomberg for 20 years, the library-based allocators that we could not live without, would come out. We take them out and use the language. And that's a strong statement. Without allocators in the language, we will continue to maintain them ourselves out of necessity. They're that important.
Wow.
Okay.
Yeah. One question back to the book for a moment. So you mentioned the 3 different volumes. The first volume is already out, and your original book came out, 20 some years ago. I'm assuming we're not going to wait 20 years for the second and third volume. It sounds like they're mostly written already.
So now I get to talk about future books real quick.
Yeah.
So there's the volume 2 and volume 3. People joke that I'll be 100 years old by the time volume 3 comes out. Well, they don't know Lori. Lori Hughes is someone that I had the pleasure of working with in producing volume 1. She is, I knew she was talented because she was able to render 3-dimensional things. She's a technical writer. She's also a project manager. And she got me to get this book out this year. I think there's no other human being that could have done it. And she was merciless, and I'm not easy to work with, especially when I get no sleep for 5 months. So it was challenging, but she and I together managed to get me to get it done. She has already put into Pearson for a schedule for the second and third books. I mean, it's not going to be done in a few months because the stuff is old and needs to be updated. But the sections are already forward referenced from the first volume. That's how, yes. Seriously, that's crazy. Yeah. So that doesn't normally happen. We're forward referencing books that don't in theory exist, but they do. So 2 more volumes are coming. If I had to give it an honest guess before Lori, I would have said in the next 10 years. With Lori, I'd say in the next 5. Now, if I beat that, that's great. But let's be real. In the meantime, I have 3 co-authors on 3 separate books. Vittorio Romeo, who works at Bloomberg, and I are putting out something based on a paper that we wrote that was approved by was seen and blessed by many senior people in the standards committee. And we call the paper Embracing Modern C++ Safely. And it's called the EMC squared paper. But basically what it is it took C++ 11 only after many, many years, like 7 years, and said, here's C++ in 10 pages, in 10, or 11 pages, C++ 11 language features. Here's what they are, and here's what to be careful about. And they're sorted into 3 different categories. And this is just to annoy people. Safe features, conditionally safe features, and unsafe features. And there are only 2 unsafe features, and it's tongue-in-cheek. There's nothing unsafe about C++ 11. What's unsafe is if you have 6,000 people at a company like Bloomberg and you start doing member references and you don't know why. Okay, when you start making things final and you don't have a company-wide policy that says we have control over all software, we can always unfinalize it whenever we need to if you just ask us, take us 2 seconds. Well, a place like Google can do that, but because Bloomberg actually open sources and makes things public, we don't have control over everybody that uses us. And so we have to make more open, like the standard open decisions. And so for us to put final on something inhibits one of the critical theses of the book and of the whole of the new book, which is hierarchical reuse. Hierarchical reuse is all about reuse, where you're not just saying reuse this logger or reuse this matching engine or something. Whenever you build something like that, you build it out of smaller pieces. And the smaller pieces themselves are useful for building similar things. And those smaller pieces in turn are built out of smaller pieces. And even a vector, when you look under the covers, anybody who's building the standard library has a whole library underneath of hierarchically reusable pieces that they use for all their containers, all the way down to metaprogramming. And so what I'm advocating is make fine-grained modular pieces that are stable and resort to hiding only when the interface between what you're exposing and what you're hiding is unstable. So having a private class or a nested class, something like that in a component, which is just a .h.cpp pair, is something that you do because of instability and no other, not because of sloppiness, not because you don't want to test it, none of that. There's also, you don't put 2 classes in the same component unless you have a reason. Again, a component is like a module. It's like a .h.cpp pair. And in fact, modules are better components. But if you don't have modules, you have components. And the way you design a module and the way you design a component are the same. And this volume heavily footnotes when we have modules widely in use, how you would do exactly what this book says using modules, but the design is no different. There's no change. So if you're interested in modules, buy this book.
And just to be perfectly clear, we are talking about C++ 20 feature modules.
Yes. Okay. And the C++ 20 feature modules was based on what I call a component that's been around for 25 years. It's the same thing in many ways. The differences are important. For example, in Lakos 96, I said no design cycles, no cyclic physical dependencies. In modules, as a result of my 2017 standards paper, there are no cyclic dependencies possible in modules, except if you do some, I don't even want to tell you how to do it. I think it's either not possible or it's so arcane that you have to be at the 5th degree black belt level to do it. That's good enough. If you really want to shoot yourself in the foot, you might be, it's not the foot, this would be in the head. The other one, long distance friendship. The two most important design imperatives that I can give anybody is no physical cycles, no long distance friendship. Modules do not permit long distance friendship. What that means is you cannot have something in one module say that something in another module is a friend. And that means that you don't have this incredible coupling that would make Parnas turn over, because Parnas really liked modular programming. Dijkstra really liked no dependencies. And so those two people can rest in peace.
I think you just challenged probably at least a dozen of our listeners, though, to figure out how to create cyclic dependencies in modules after they hear
I'll
this.
try to stamp it out in the next release. It is something that it's horrible. You should not do it if you do figure it out. Another thing that modules bring to the table that's really good is it gives you control over what we call transitive includes. And an example of where a module is just awesome, it stops you. You can have a type that's used in the implementation of a type that's public. Let's say it's a data member of the type. An example would be I have a box. The box has 2 points as data members. Okay. I don't want to publish point because I've got a better point on the way. So this point is just temporary, right? But I don't want people to use my point, but I want them to use my box. In old-fashioned header files, I'd have to make the point type available and they could create instances on their own. With modules, we can stop that from happening. That means that if you need it, you have to include it yourself. That's a rule. That's a great rule, because if you don't do that, somebody can change their implementation and client code can stop working for no apparent reason. So the reason we want to do this is we want to say, if you want to use point, you have to import it yourself. And if we don't want you to import it, you won't be importing it. Done. And that's a great thing. That gives you the encapsulation you need, the control over encapsulation. What modules don't give you, because modules are obviously the best thing since sliced bread, what modules do not give you is what's called insulation. In the first book, we talk about insulation is I can insulate an implementation detail, and clients, when I change it in my library, clients of the library don't even have to recompile. Whereas if it's encapsulated, they might have to recompile, but they don't have to rework their code. So modules do wonderful things for encapsulation. They do nothing at all, period, for insulation. And if you want that to happen, it isn't going to happen. Now, we could take modules a step further and we could make them fine-grained views. And what that means is, suppose you write a stack class or something, and I'm giving this only as a toy example, and, push is working great, but only the real experts are allowed to use pop, because we've been working on that for a while. We're not sure. You could provide a client with a view that treats the stack class as the same type, but is enabled for only push, but not pop. You could then give another client full access. You could give yet another client access for pop, but not push. Then you could have a client using all three, and they would inherit and take the union of the capabilities of each of the people they import, or the units they import. And so at the very end of the day, there'd be a lot of different people accessing the same type. There's no ODR issue. There's nothing like that. And one more thing we'll mention, because we're in the early stages of this, you can imagine that it's not the same thing as hiding the functionality, because someday you might expose it. So it's treated much more like an inheritance hierarchy and overloading. If you have a deep inheritance hierarchy, which we don't recommend, and you have a private type at the bottom that's a better match than the public type at the top, you'll match the private type and then be told no. Right. And the same kind of thinking would apply to a view on a subsystem. You'd be told, yeah, you'd love to use this, wouldn't you? Yeah, call the company and see if you can get it, because right now we're not going to let you screw that up. We're not going to make it so that when we give you a different view, your code changes behavior, because somebody could reasonably argue that that's dangerous. So we won't let that happen.
Well, this topic leads me to think about the current ongoing discussion, and I know you're getting ready to head to the standards meeting, so if you don't want to talk about this too much right now, that's fine. But ABI, breaking ABI.
Okay.
where do you have thoughts on that? Like you're at Bloomberg, you're at giant organization with lots of code. You just talked about the fact that you open source a lot of stuff, and you have to take decisions. You can't make decisions lightly in your design. But if you need to break ABI in your code, is that a good thing? Are you good at recompiling? What direction do you think the standard should take on this as this conversation is evolving?
Yeah, I think that's a really good question. I think that what we've done is we become such a slave to it that it can be really crippling. I mean, you can imagine the other side of the coin where we changed it all the time, and people could also be very frustrated. My own personal experience is that we have old platforms like Sun, and because of Sun, it's kind of like we can't do anything fun because we have to stick with stuff from really like 1998 C++. We have to stick with really, really old features. And in a way, it's like we don't have any options. We can't use PMR. So we have to stick with our own version of allocators, you know, that were PMR 20 years before that we had PMR, you know, and we can't get off of that. So I don't know what, I mean, there are two sides of the coin. There really are. What I would like to see, honestly, once we perfect our allocator technology so that it's language-based, and if we can sell that to the standard, I would like to see the issue of SDL2 revisit. You know what I'm saying? A new SDL that has all of the mistakes of the last 30, because I'm looking ahead, 30 years removed. And then you say, okay, I'm either on or STD or STD2. You just say, and that is a fork, but it's a clean one time, because I won't be alive for STD3. So it's a clean one time. And the advantage of doing it after 20 years just because of ranges was probably not enough. But if you have ranges, modules, and no more allocators in the code, yet fully handled, and now you have a new way of doing business, and you can get rid of all of the warts that came from the way we overspecified certain vector things and whatever. I mean, having certain operations have the strong guarantee just turns people on their heads for no really good reason. People were a little premature to promise more than they needed to. And so, you know, when you have node-based containers that have embedded sentinels and all the whole issue of radioactive types after moves. Oh, moves are another thing. Let me just say this just to annoy people. Move isn't all that. And if you don't use allocators, you'll get memory diffusion and your code will slow down over time. And if you're not careful with moves, you'll get memory diffusion and your code will slow down over time. So when you're writing libraries, be really careful. If you're copying stuff, move as an optimization. And if it's reasonable to do it, you do it. And if it's not reasonable to do it because you're going across a memory boundary, then you'll copy and you'll be better off for it. On the other hand, if you're not copying right now and you say, but I can make it move, stop. Think of what you're doing. You're hurting yourself. You're shooting yourself in the foot. You're making your code incredibly hard to test for absolutely no reason. We have unique pointer, and that is a separate piece of functionality. Now, I have talked to many, many people on the standards committee and asked them to tell me I'm wrong. They don't tell me I'm wrong. So move-only types, I'm going on the record right now as saying there are about 11 of them. The first and foremost is unique pointer. There are a handful of descriptor-like things that have active destructors, file handles, sockets, shared memory handles, thread handles, and that's it. And they're all descriptors in an operating system, and you don't need anything else because as soon as you're allocating memory, just use unique pointer and call it a day. Otherwise, you're going to pay a heck of a lot for something you don't want to use and you don't need to use. And now magic trick, right? In C++ 03, you could use a undeclared copy constructor and in place value, return by value, something that isn't even copyable or movable as a factory function. C++ 11, you can do that same trick with move. In C++ 17, you don't need to use that trick anymore as long as you return the type as a PR value, which is just composing it and returning it I'm going to propose in 23 that we do a little named RVO so that we can create an object, beat on it, return it, and now factory functions don't need copy or move at all, and they don't need to cheat. By the way, the cheat that I told you is safe because it'll either work or it won't link. I'm not doing something dangerous.
Right.
Okay, just to make sure everybody knows. So I've the cat's out of the bag. Move only types. Somebody tell me I'm wrong and give me a counterexample. I want it. I'm asking. Seriously.
Okay. I'm sure some listener will take you up on that. Maybe.
Bring it. Bring it. No, I mean that in the nicest, most cordial possible way, because if I'm wrong, I want to know it. I've asked everything I can.
How should they deliver their example to you?
Well, let me ask you, that's a good question. How about, I don't know if it's appropriate, but I will tell you this, if you're that determined, go to the standard website and look up any of my papers and you'll find my email on one of the papers. How's that?
Okay, that sounds good.
That works.
And I think many of our listeners would already know where to find that, so.
If you're that good that you know where to find it, then I want to hear from you.
Okay. We've been talking about how you've been working on this book over the past 20 years. We just spent some time talking about modules and move semantics. How has the evolution of C++ affected what's gone into this book, with C++ 11, 14, and 17?
Sure. So again, this book shaped C++ 11, 14, and 17, not the other way around. I'm not kidding. I've been in the standards committee for a long time, and I've been feeding this stuff there. This book didn't change. Modules changed to reflect components. My style of development has not changed at all when it comes to designing the components, packages, and package groups that make up an enormous system. Now, move semantics is important. Allocators are important. All of these things are very important in Volume 2, which will not... Volume 1 was written to the C++ 98 subset of C++ 20. That's another way of saying it was written in 98. But there are tons of footnotes that address language features that could be used if you have a higher level, but you don't need any of them to design at this level because we're talking about macro pieces. It wouldn't even matter what language you were in, hardly, let alone what version of C++. The reason I chose what I did is I want architecture to be approachable by anybody who knows C++. And you're not going to design differently at that level. You're just not. You're not going to have different dependencies. So that's it. I will say, however, that the evolution of my knowledge of generic programming and callbacks, whereas I talked about levelization techniques in Chapter 5 of Lakos 96, levelization techniques is Section 3.5 of Lakos 20. And that is in the callback section, there are now 5 subsections which talk about different kinds of callbacks, data callbacks, function callbacks, functor callbacks, virtual callbacks, and generic callbacks. And generic callbacks are crazy powerful things. And please keep in mind that you can use virtual functions and get polymorphism that way. You can use templates and get polymorphism that way. They are similar and they are different. And the book explains how they're similar and different. And the book says it in much the same way that Matt Austern did back in 2000. But Matt Austern, of course, was much more avant-garde than I ever was about templates. So now I understand. So the book will make it clear at that level as well. So did I answer your question? No change. So. No change at all for Volume 1. Volume 2, yeah, we'll talk the same underlying concepts because it's software engineering. The other thing I want to say is this book is not a book on C++. It's a book on software engineering. And that is probably the most important difference between most books. If you get a book on C++, it'll teach you about C++. If you get a book from me, it's about software engineering using C++, and it's a very, very different beast. Comes from a very different place, and its longevity is much, much greater. Lakos 96 is still correct.
So then would you say this book is relevant to and has concepts that are meaningful to people who don't use C++ and are working on large-scale projects?
Absolutely. Absolutely. 100% translatable to Java Any programming language that has separate compilation units, this is the right book. You just won't be able to take full advantage of the nuanced control that you get from C++. The only missing piece of nuanced control right now is having memory allocation be part of on the per object interface. That's the holy grail. The last thing that separates C++ from the hardware is you might need to be between C++ and the hardware for placing objects in memory. That's the last place. And this will take that away. This will remove it. And now C++ will be lacquered to the hardware.
So what, I'm curious, you've talked a lot about this proposal that you said, well, we'll remove allocators from the interface, but still make them available. What does it actually look like? What would the users of this see?
May I make a reference? If you want to go to Halpern and, no, it's Alistair and Pablo, Alistair Meredith and Pablo Halpern, CppCon 2019, Getting Allocators Out of Our Way.
Okay.
There's an entire hour that talks about what we're talking about. So again, CppCon 2019, Meredith and Halpern, or Alistair and Pablo, I don't know which it is, Getting Allocators Out of Our Way. It's as simple as this. When I go to take a simple type that is an allocating type, I have to add an extra constructor, an extra argument to each constructor to make sure that I can add an optional allocator.
Right.
That allocator is stored in the object, the pointer to the allocator, and then used to allocate memory.
Right.
Mostly right now, people don't use it, and people might say, well, that's extra overhead and whatever. Please look at any of my 2019 talks. That's not true. It isn't extra over. It's not measurable. Please look at my 2017 talks, particularly my Meeting C++ 2017 talk on allocators, to see just how powerful they are. We're not talking a little bit of power. We're talking in certain build-up and tear-down situations, just how fast the allocator works when it's not encumbered by synchronization can give you a factor of 4 out of the box.
Okay.
When you're talking about long-lived programs, the actual allocation algorithm doesn't matter. It's the locality in memory that's devastating. And if you don't use local allocators, you diffuse memory across all of virtual memory, and then what happens is you get a low density of your working set per page, and then all of your caches and your physical memory are not doing what the machine was designed to do. And so I really want to emphasize that allocators give you and allow you to get and keep performance, and they're super duper important for that, but they have many other benefits. And when you start to weigh cost benefit, the only real cost is not to the user of allocator-aware software. The only cost is to the software infrastructure group that implements it for them. And that cost is real. However, if it were done by the compiler, so all you did was write the class, and it were very much like virtual functions, where the compiler figures out, how to manage the allocator and when to use it and all of that, and all you have to tell the object when it's constructed outside of the signature, and I'm making up the syntax, don't hold me to this, you just say what you would have said before, using and then an allocator. Just give it the name of the allocator, and you're done, and nothing's different. And now all the constructor overloads are gone, all the documentation boilerplate is gone. No one needs to know that they're writing allocator-aware software, even in infrastructure, and now it's usable and interoperable with all modern C++, generated constructors, generated assignment operators, aggregate initialization, lambdas, you name it. It's all good. If that happens, there is no cost-benefit analysis. There's nothing to talk about. We're done. I just want to emphasize, go look at that talk. Give me support. Bloomberg is supporting me. Everybody should support me. If I get this done, no one will ever need to see an allocator again. Gone.
Okay, I'm going to put the link to this talk in the show notes for anyone who wants to go watch it. Yeah,
I strongly encourage it. It's just in its infancy right now. It's nascent. I've been told by my management I have to have a working demo of this compiler by the end of this year.
Okay. So you mentioned offhanded contracts earlier in the interview, and as we know, they were...
Fun.
What's that?
That's the fun one.
Yeah, they were added and then removed from C++20. Are you working towards a future direction for standardization of contracts right now?
Okay, well, as I said, one of the books, one of the 3 co-authored books, I don't know if I got to all 3. I gave one of
No,
them.
you didn't, yeah.
Let me tell you the second one. The third one is actually Rostislav Kolebnikov and I are co-authoring a book on contracts. We're going to be publishing in the same publisher. Target date for that is about 2 years. But we're also writing a series of papers. The thing about contracts that I think is difficult is, of all the engineering that we do, contracts fall into that gray area. But I'm going to finish up on contracts, but I just want to mention Joshua Burney and I are writing a book on allocators for the working programmer so that we can show you why they're good without being too pedantic. So that said, let me get back to contracts.
Okay.
So contracts, all of these 3 co-authored books are in a 2-year time frame. Just letting you know. Okay. And we need them because we need people to realize how important they are. And when contracts are available, and I'm pretty sure they will be in 23, we want people to take full advantage. So the thing about contracts are if you're doing contracts right, if everything is right, you're having absolutely no effect on behavior, which is a really bizarre thing to say, if everything is good, because a contract check is a defensive check. What's a defensive check? What are you defending against? You're stating that this thing that I'm checking cannot happen. Cannot. Mm-hmm. No way. I put my sign. It can't happen. So the simplest version of this is I write a very elaborate averaging. I want to get the mid-range of 2 integers. Now, to do that properly, I have to do some funny stuff. I can't just say a plus b over 2 because I could overflow.
Right.
So I have to do some funky stuff like a over 2 plus b over 2 plus, what is it? A much. You have to do that long, kind of funny, expanded thing. You could get that wrong. Now, the right way to do this is using test drivers. But another way to do it is to write an assertion right after that says, as long as the numbers are small, it better be the same as a plus b over 2, right? So you could say if abs a and abs, if abs a is less than 1,000 and abs b is less than 1,000, then it is a plus b over 2. There's no overflow. You could do that. And that would be a redundant check. You don't need to write that if you've tested your program. So anytime you write a check that by inspection locally, it's shrink wrapped, you can't get it wrong, it's redundant, you can turn it off, and the logic of the program is the same. The only thing that changes is performance. The next step on that is to say I'm going to have a precondition check. A precondition check is a defensive check. What are you defending against? You're defending against misuse by trusted clients in your shrink-wrapped program. So when the program is all said and done and compiled and linked, nobody can change the calls. The library is hooked up to the app. It's one program. And then those checks that you have to make sure that the thing wasn't called out of contract are redundant. Now, once you run this program for long enough and none of those checks fire, you say, I'm good. You turn off the checks and the program runs faster and life is good because the program is mature. That is a defensive check. Now let's look at the other side. What is input validation? Input validation, I have a config file or I have a customer data coming over the wire. Do I trust the customer? Hell no. It's a trading system, so I'm not going to defensively check against that the data is valid. I'm going to validate it in every build mode forever because no matter how good my program is, any new customer comes along could kill me. Mm-hmm. That's input validation. Now you might say, well, wait a minute. What if it's my own config file? I wrote it myself. It's good. Life is good. Now the question becomes trickier. Who's putting the config file there? Is it shrink wrapped into a container or is it, Joe put it in today and somebody released this thing tomorrow and they're inconsistent. So the wisdom is, unless it's shrink wrapped together by dint of being compiled program, or you have some kind of module, container, something, package where you deploy the whole thing at once after it's been tested and it cannot come unglued, then the check is an input validation check, not a defensive check. But if you can absolutely guarantee that it's been shrink wrapped and tested, then the internal defensive checks can be removed and there's no change in behavior and no risk of it's getting out of sync. So that's where contracts are hard. And certain people on the standards committee do not understand that a program with no contracts, a program with some contracts, and a program with all contracts enabled are the same program, assuming that the program is correct. And if the program isn't correct, then having a contract that checks and continues is no worse and infinitely better than not having a contract at all. There's a misunderstanding of what's going on there, and that misunderstanding, because it's not easy to appreciate if you're not a real day-to-day software engineer, that is what derailed contracts. I will fix it.
Okay.
I promise you I will fix it. In fact, I think everybody is getting to understand that contracts are a different beast, and that if you write contracts properly, they have no effect on a correct program, and they don't defend against anything with a correct program. They don't defend against bad input with a correct program. They do nothing with a correct program. If your program is incorrect, it means you didn't test it. You should go back and test it. But once it's all working, leave the contracts effective for a little while, make yourself happy, then turn them off and buy less hardware. Okay.
Well, I'm looking forward to contracts. It was one of the things I was looking forward to the most for C++ 20, because even forget the design or any question about the design, any tool that helps us validate software, I'm good with.
And
I'm
just
interested in.
There are 3 reasons for having contracts, I believe. One of them, what was it? There's sort of 3 different camps. One of them was making software safer. I think that was one of the things. And one of them is making software faster, because once you have assertions in place and you know they're true, not checking them is faster than checking them, but assuming that they're true and letting the compiler optimize based on them is even more.
Right.
And so runtime checks, awesome. Compile time checks for static analysis, awesome. Speeding up runtime code based on optimization for the compiler, interesting. All 3 of them together for free, because it's a Trojan horse. If you have contracts in place, anybody can do static analysis.
Right.
All right.
Well, John, I think we're running out of time, so we'll let you go. But thank you so much for coming on today, and I encourage listeners to check out the book.
Well, I thank you very much for having me, and I think I managed to touch on everything that I was hoping to touch on, and thanks for asking about contracts. We're going to do our best to get them in as soon as possible to 23, and let's not wait till 26. I want everybody who's interested in getting them in by 23 to write your congressman or write your language designer and say, yes, we want contracts in 23.
Okay.
Okay, sounds good. Thanks, John.
All right, take care.
Thanks.
Bye.